All right, let's continue our discussion of extrema by picking up where we left off Monday. And let's work example 5. Find the absolute extrema of the function 3 over x minus 1 on the interval from 1 to 4. All right, just before we jump in and do it, does anybody know what this graph kind of sort of would look like? It's going to be a Hader graph, right? Okay, because it's also the minus 1 is with the x, so it means it's going to shift left or right, but opposite the number. Is that a horizontal shift? So it's going to shift right 1. So kind of sort of something like this. Normally Hader graphs hug the x-axis and the y-axis, but if we shift that to the right 1 unit, it's going to look, something like that. Okay. Question is, on the interval, and I do need to adjust this. That needs to be a parenthesis. Why does it need to be a parenthesis? Because there's an asymptote at 1, so the end point cannot be included. Okay, but starting at this point, so I'm actually interested in what happens from here to here, from 1 to 4, not including 1, but do including 4. Everybody okay? Okay, absolute extrema. Can anybody tell me what my maximum might be? Can there be a maximum if you have an open end on the left-hand side of extrema? Because looking at your graph, there will not be a what? There will be no absolute maximum. Does everybody understand? Because even though I'm starting at 1, 1 is my asymptote, and even if you say, well, let's go, barely to the other side of 1. Is that 1.00001 or is it 1.00001? It would be really hard to actually put a value on it because you could, it's almost infinitesimally could be large. Everybody understand that? Okay, so no absolute. Would there be a absolute minimum? Where do you think it's going to be? Wherever it touches at 4. Calculate it for me. So where is the absolute min? At over 4 and up 1. Because if we put 4 minus 1 is 3, and 3 over 3 would be 1. So I know there is no absolute, but there is an absolute min.
Because like in our homework, it felt like we were just finding the critical value, but then we didn't really use it because we just found the max and min.
Critical values tell you where the max and mins could be.
But if you have an interval.
If in this case, the reason this example is on here is because even if I try to take the derivative of that, I'm going to end up with something that I can't really solve. There are no critical values for this particular problem. Okay, so if I tried to do it, the first step I'm supposed to do is take the derivative. Well, I'm going to rewrite this as the function f of x is 3, and I'm going to bring this where? Up to the top, and make that x minus 1 to the negative 1 power. I'm going to take the derivative of that. So what do I get? The first derivative is negative 3 times x minus 1 to what? The negative 2 power. When I rewrite that, I get negative 3 over x minus 1 squared. And here's the thing. Even if you take the derivative and you set it equal to 0, that's not solvable, is it? There's no way. So I have no critical values. There's nothing in the interval that I can check. So in the cases like that, no critical values to check. So what do? Look at the endpoints. That's the reason that I included that particular example. if you solve and you can't get anything, that's critical. And of course, looking at the example, oops, let's hit the bot. Looking at the problem, the way it's written, or kind of understanding a little bit about what the graph looks like, there's no way that I'm going to have anything. There's no maxes or mins. There's nothing that happens in between here and here that's going to allow me to find anything else. Question?
How is that unsolvable? Because couldn't you just move the x minus 1 to the negative power up to the top, and then divide by -3, and you get 0, and then just keep working like that?
I think I get, okay, think of it like this. This right here is not solvable, right? It's not solvable because anytime, let's just look at this side. The only way that I can have a fraction and get an answer equal to 0 is if the numerator is a 0, right? You can't have a 0 in the denominator. So the only way I can get a 0 equal to 0 is if something on top. So what that would mean is 0 would have to equal -3, and that's not true, right? That's a false statement. Does everybody understand what I'm saying? If you cross multiplied, you're going to get -3 equals 0.
So you have an x in the numerator, you have a possibility.
In a different equation, but not on this one. Yeah. So see, even if I tried to cross multiply right here, I would get 3 is equal to 0 times x minus 1 squared, and 0 times anything is going to be, or -3 is equal to 0. See what I'm saying? I can't solve it. So in this particular problem, I ended up with an equation. They gave me a function that's not solvable if I set it equal to 0, which matches what it should tell me. It tells me there is nothing to solve for. There are no critical values on this interval. Is everybody okay with that? So that's why I included that example. Huh?
It doesn't matter what number you have in the numerator. X is not going to work.
Right. If you don't have an x in the numerator, yeah, it won't work. If I did have, like, if I had, let's say 0 is equal to 3x plus 4 over x minus 1 squared, then I could solve for something, right? Because the only way I can have a fraction and get an answer equal to 0 is if whatever's on top, it becomes a 0.
So can you just take the top?
Yes, you do. That's how you would solve that. I mean, even if you cross multiply, that's still how you would solve that, right? Okay. No, go ahead.
Okay. Why do you set it equal to 0?
I'm going to pause this. Hang on. All right, let's look at example 6. Example 6. What does that graph look like? It's so easy. It makes your life a little easier if you remember what the graph looks like. It's half of a sideways parabola, isn't it? So if I remember that it's half of a sideways parabola and the interval does start and includes 0, and it goes all the way up to what? 4, and it includes 4. That's the interval right there. I shouldn't really need to go through the process of doing first derivative, right? Because I'm not going to be able to solve it. Are there any critical values between here and here? No. What is my absolute max and min? If I'm given something on a test or a quiz and I know what it is, I know that right here is going to be my what? That's my 0, 0 point, and that's my absolute minimum. And this one up here is 4 what? 4, 2. So 4 comma 2, this is my absolute max. Okay? I'm just looking for those lows and highs. In this case, this one doesn't twist or turn, so I know that's it, and that's it. Okay? Could we take the first derivative? Could we set it equal to 0? Yeah, we could go through the motions of that. But if you know what your graph looks like, I don't think you need to just trudge through the mud doing something like that if you don't need to. All right. Yes, question. No, that one would not have a min or a max. No. Did everybody hear that? If those were open intervals and it didn't include 0 and it didn't include 4, there would be no absolute max or mins. Well, the endpoints are not included. So what that would mean is I'm really as close to 0 as possible, but not exactly 0. How close is that? Is it 0.0001? Where's it? 0.00000001. And someone say, oh, if you put a million zeros in a 1, I'm going to put 20 million zeros in a 1. So there's no way to define how close that value is, so you actually can't put a number on how low it's going to be. Do you see what I'm saying? That would be no no solution or no max or no min if the endpoints are not included. All right, find the extreme of the function. I do not know what this one looks like. Do you? So in this particular problem, we don't have the benefit immediately without grabbing a calculator, and you may not have your calculator, of being able to tell what this looks like. So we are going to go ahead and follow our process. What's the first thing I need to do? Find the first derivative. So the first derivative of my function f of x is going to be 2 minus 3 times 2/3 x, and then what? Well, it's going to be to the negative 1/3, exactly. All right, we do have something, and you're right, the 3's are going to cancel, so I'm going to equal 2 minus 2 over the third root of x, or x to the 1/3. Now, if I set it equal to 0, can I solve this? We can. If you move it over, can we subtract the 2? So I get negative 2 is equal to negative 2 over square root of 3. I think I know what the answer is, because anybody figured it out yet? Square root of what number, or excuse me, cube root of what number would end up being a 1, so that negative 2 divided by that is going to equal negative 2. 1. You want to solve it? You want to go through the process of solving it? Okay. I like to cross multiply things to make it easy. Let's cross multiply. What happens if we cross multiply? We're going to get negative 2 times the cube root of what? X, which is equal to negative 2. Everybody good with that? Now, I'll need to get my cube root by itself. So if I get my cube root by itself, I need to get rid of the negative 2. So how to get rid of it? Divide by negative 2. What's negative 2 divided by negative 2? 1. So now I have the cube root of x is equal to 1. I don't want the cube root of x. I want x. How do you undo cubing something or cube rooting something? You're going to cube it. So if I cube one side, I want to cube the other side. So finally, cubing it and cube rooting it cancel each other. X is going to be equal to 1. I do have one critical value. Positive, no, not with cubes. Not with cubes. We don't need to do that. And besides, I'm also restricted by my interval. Does my critical value fall in my interval? Yes. So now what I need to realize is, because I'm doing absolute max and min. Okay. Since I'm doing absolute max and min, I have 3 points to check. What are my 3 points? I'll get your question in a second. What are my 3 points? All right. I'm going to check negative 1, 3, and then what? Positive 1. Okay? So I'm going to check my 2 endpoints, and I'm going to check that I could have one of each. Okay. Okay, if you plug it in to find out the point, you don't go to the derivative. You go to the original. Guys, what's 2/3 mean? What's 2/3 mean? Let's review our rational exponent. I'm taking cube root of whatever my x is. What's the cube root of negative 1? Negative 1, because you can take the cube root of negative numbers. So the cube root of negative 1 is negative 1, right? What number times itself 3 times is negative 1? Negative 1. Now, I'm going to, top number says that's my power. So I'm going to raise negative 1 to a second power, which squares it. What's negative 1 squared? It's going to be positive 1. So I've now taken care of my rational exponent. I don't want you to have to grab your calculators. It's been a little while since you probably worked with rational exponents, right? Yeah. So if I rewrite that, isn't that like the cube root of x to the second power? You can do it that way, or you can do the cube root of what? X to the second power. You can put your power inside, or you can put your power outside. By the time you do both root and power, you'll get the same answer either way. Does everybody understand? These numbers are such that you probably can do most of it in your head. Okay? Maybe not the 3, but go. Do the. Okay, I would probably have to only check one. And I would go, if I was doing a sine line, I'm going to erase this. When I do a sine line, I'm going to put 1 in it. And all I'm interested in is it positive or negative, slope-wise, coming up to my 1 point. And then what is it doing to the right of my 1s? I'd probably pick 0 and 2 or something in between. Yeah, you just plug them in here and plug them into your first derivative, and you're going to ask yourself, is it a positive answer or a negative answer? That's all you need to know is positive or negative. Yeah, that's checking if the slope is increasing, coming to that critical value, and if the slope is decreasing or increasing, moving away from it. Huh? If you used the 3. Did y'all get -5? First one is -5. So that point is -1 and -5. That looks pretty, it doesn't seem like it's very high on the graph. Now 3, to the 2/3 power. That's not going to be nice and neat. That's going to, which would be, all right, all I need to know is that's not quite as low as this, but it could be the highest point. All right, what about +1? Oh, it should be minus. Did you get -1? All right. What's my highest point? What's my lowest point? Huh? That would be the highest point. And then the lowest point. -5. So we have an absolute. Sine line really only applies so much when you're doing relative. You all didn't have to do sine lines, SIGN, on your homework, did you?
And that's why I'm so confused.
Or check the change in the slope. Usually it falls in between. Yeah. Usually it falls in between. Yeah, it could be. So let's see. Have y'all graphed this? Grab your calculator and graph the original function.
If the critical value is not going to be a maximum in, why would we want
It could be a relative maximum in.
So critical value is mostly.
What does this look like between? Man, I wish I had got to come in and get my notes ready before I started. All right, as a wrap up of number 7, I will come back and revisit number 7. I will come back and revisit number 7. I promise you. All right. Hey, number 8. You do need to do this one because we didn't do any others that had sine and cosine related to them, right? Okay. Find the extrema. I do not necessarily, I know what a sine curve looks like, and I know what a cosine curve looks like. I don't really know what happens when you start adding and subtracting these trig functions. So I'm going to go back and rely on what I previously have done, which is take the first derivative. Derivative of 2 sine x is 2 times cosine x minus, will actually be plus, sine of 2x times 2. Let's say, which is going to be 2 cosine x plus 2 sine 2x. Sine 2x. Ding, 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 ding. Double angle formula.
Oh my
Okay? Who remembers the double angle formulas? On your note cards, I kind of asked 2 sine x cosine x. So I'm going to replace that. 2 cosine x. We already have 1, 2. So what are we going to end up with? And then this part's going to give me a 2 sine x times what? Cosine x. So I'm actually going to end up with what coefficient here? 4. Can I factor out anything? Because I'm going to eventually have to set this equal to 0. So it's going to be to my benefit to try to do something with this. So I'm going to factor out not only a cosine x, but also a 2. So 2 cosine of x factored out. What would be left? 1 plus, no, factoring out one of the 2's. One of the 2's is left, sine x. Now, have I simplified my first derivative? Okay, now, I'm going to set that equal to 0. Yay! By having parentheses, by having 2 products, and that's what I have. Well, do you remember the 0 product property? If I multiply one quantity times another quantity, and the answer is 0, then the only way that could happen is if either the first one's 0 or second one's 0. You did that most commonly when you had factors of a quadratic. So like you'd factor like x squared plus 3x plus 2, you'd factor it like x plus 1 and x plus 2. And if you were trying to figure out what makes it equal to 0, remember doing it that way? So it's the same idea, 0 product property, only now we're doing it with trig functions. So we're going to set each one equal to 0. So 2 cosine of x, set that equal to 0. So divide by 2. Cosine of some angle x is equal to 0. I'm actually looking for a point on the unit circle. That would be in my interval, which I believe is from 0 to 2 pi, which is a complete 1 revolution around the unit circle. So when does that happen? When is my cosine, or what angle gives me 0? Pi over 2 and 3 pi over 2. Is everybody good with that? Okay. So far, x is going to equal pi over 2 and 3 pi over 2. Those are possible critical values that I'm going to check. And that does it doesn't really go against what I think, because don't we have a lot of peaks and valleys with sine? So we could have multiple places where we have maxes or mins. Okay, that's only one possibility. Now we got to check what? 1 plus 2 sine of x equals 0. Subtract 1. So sine of x equals negative 1/2. Where on the unit circle is the sine equal what? Negative 1/2. That's a y value. So it'd be 7 pi over 6 and 11 pi over 6. Okay, everybody good with that? So x is equal to 7 pi over 6 and 11 pi over 6. All right, is everybody okay with what we just solved? We haven't really done very many of those at all. So you would have last had that probably with Ms. Patterson in pre-cal. Everybody okay? Are we done? Those are just critical points. So how many critical points do I have? 1, 2, 3, 4, but we're doing absolute. So we also have what? 0 and 2 pi. There we go. Okay. Now, what we have to do is we have to put back into the original function. If your calculator's in radian mode, and they all should be, right? Unless you're coming from physics, which you might have changed it to degree. You might be able to do it in your head. I can do some of them in my head, but I don't know if I can do 7 pi over 6 and 11 pi over 6 in my head for sine and cosine. But we probably can. We probably can. Are we ready? Let's do one. So let's take the function and put my first critical value. Let's just put 0 in there. Everybody okay? So it's 2 times sine of 0 minus cosine of 0 times, or 2 times 0. Sine of 0. No, sine of 0 is 0. So it's 2 times 0. Okay. Okay, 2 times 0 is 0. What's cosine of 0? 1. So I'm going to end up with 0 minus 1, which is negative 1. So I'm just going to, yes, ma'am. I'm going to multiply it by the angle, then take the cosine. So it's because it's 2 times x. So you're going to have to input your multiply by 2, and then take cosine. Yes. You understand? So like right here, I substitute in 0 here, then I substitute in 0 over here. So 2 times 0 is 0, and then cosine, yeah, and then do cosine of the answer. So far we have a point what? 0 and negative 1. We're going to repeat that. The function at, I'm going to try this one, pi over 2. 2 times sine of pi over 2 minus cosine of 2 times pi over 2. Before I take cosine, what's going to happen with 2 times pi over 2? The 2's are going to cancel. Okay, what's sine of pi over 2? It's 1, right? It's the y-coordinate. So if you go to pi over 2, go up. So this is going to be a 1, so it's 2 times 1. Minus what's cosine of pi? That's going to end up being cosine of pi. Cosine of pi over here is an x-coordinate of negative 1. Is everybody following me? Okay, because there's every chance, and it's minus a negative 1. So you're going to end up doing what? Adding 1. So 2 add 1 is 3. So now I have pi over 2 gave me an answer. It goes as high as 3. Does everybody see what we're doing? There's every chance that you'll be asked to do this without a calculator. Okay? How about the function at 3 pi over 2? Equal to 2 times sine of 3 pi over 2 minus cosine of 2 times 3 pi over 2. All right, what's sine of 3 pi over 2? She's got it, negative 1. 2 times negative 1 minus, okay, again, my 2's cancel, don't they? What's cosine of 3 pi? That'd be like going all the way around, and then all the way around again. Negative 1. Does everybody see? Okay. Now, see if typing it in your calculator would work. I mean, since we've slugged through the first 3, can you do the pi key divided by 2? Just see if that works for you. Okay. Since we've slugged through a couple of them, so this is still going to be negative 1. Negative 2 minus negative 1 is negative 3. Sorry, adding be negative 1. Negative 1. So at 3 pi over 2, we're getting negative 1. And we could do that for all of our 6 critical values. Is it fun? It's important, though, to know how to do it if you're asked to do it. Chances are on the AP exam, they probably, I don't think it's at all out of the question for them to ask you to do this. I don't know that they would give you 6 critical values and make you check all 6. I don't think they would do something that's like time consuming without a calculator. Okay.
Like if they don't take high school, they go straight to college.
All right, we slugged through going through the calculations. We put 7 pi over 6 in our calculator, and we were able to verify that negative 1.5 actually is what we get on our calculator. Now looking at the answers, 3 is as high as it gets. This makes it our absolute what? Maximum of all of the important values. And then we actually have, the lowest it gets is what? Negative 1.5, and that happens twice. So we actually have 2 absolute minimums. So it does look like if you're only doing absolutes, like the homework apparently was, you're not doing that sign line, you're just basically checking the high and low points by substituting back into the original function. Okay? And that wraps up the rest of the notes from Extrema.